Hello everyone. My name is Jawahar Amr Al-Jabri. I'm a senior at Dubai National School, Al-Tuwar, and today I'll be explaining a part of Gibbs free energy and chemical equilibrium from our AP Chemistry course, lesson 17.6. The part that we'll be discussing today is how can we predict the direction of the reaction depending on the values of K and Q, where K is the equilibrium constant. It's the ratio of the concentration of products to the ratio of the concentration of reactants, and Q, which is the reaction quotient, is the quantity that changes as a reaction system approaches equilibrium. Let us see the difference between K and Q. Let's proceed with a common example which starts with A capital plus B capital, reversible, C capital plus D capital. As you can see here, we have the equation for both the equilibrium constant and the reaction quotient. As you can see, they look very similar to each other, but the difference between them is that the Q is happening at any stage and K is always happening at equilibrium. Now for the comparison between Q and K values. We have to understand first that Q tends to always want to be equal to K, as I said previously. That is why when Q is less than K, Q will want to increase itself so it can be equal to K, which will make the reaction proceed in the forward direction. And when Q is more than K, Q will tend to decrease itself so it can become equal to K. And lastly, Q, which is equal to K, means that the reaction is at equilibrium. Let us now see how this can be achieved. First, when Q is more than K. When Q is more than K, it means that the products are more than the reactants. So the products will have to reduce itself to reach equilibrium. The reaction here favors the reactant sides, which is the left side, and it is moving in the reverse direction. In our second case, when Q is less than K, when Q is less than K, it means that the reactants are more than the products. In this case, the reactants will have to reduce itself so it can reach equilibrium. The reaction here favors the product side or the right side, and it's moving in the forward direction. The last case, Q is equal to K, which means that the reaction is already at equilibrium. It has no net reaction. For a reaction spontaneity. For a reaction to be spontaneous, we have to have Q less than K, which means our delta G is going to be less than 0, which means we have a spontaneous reaction towards the product sides. Second, when we have Q is equal to K. When Q is equal to K, delta G is equal to 0, which means the reaction is at equilibrium. Lastly, when Q is more than K, when Q is more than K, delta G is also more than 0, which means the reaction is not spontaneous. Thank you for listening, and I hope you enjoyed and learned something new today.